Hello guys, it's Miss Ru again from Mathematics Hub. Today we want to look at differentiation from first principles. We will differentiate different functions using the first principles. Firstly, we need to know what it means to differentiate a function. Well, differentiation is just a process of finding the derivative of a function. The derivative of a function is also known as the gradient function. It represents the rate of change between two variables, say x and y. Unlike a straight line that is a constant gradient at any point along the line, the gradient of a curve varies depending on the point on the curve that we are considering. You will notice that the gradient of a curve at a point is equal to the gradient of the tangent to the curve at the point that we are considering. Let's assume now that we are given a function y is equals to f of x. Then the derivative of that function is given by any of the following: dy dx, f prime x, or y prime x. So now, if we are given y is equals to f of x, then the derivative dy dx is equal to the limit as c goes to 0 of fx plus c minus fx all over c. So that is the formula that we are going to be using to find the derivative of functions. So now let's see how we use this formula in an example. The question that we want to answer is saying, using first principles, find the derivative of y is equals to 3x. So first we write our formula, and now we are substituting the function that we have into our formula. So now if we substitute x plus c in place of x in our given function 3x, we have 3 and open our bracket x plus c minus 3x all over c. We expand the brackets, we have 3x plus 3c minus 3x over c. You will see that 3x minus 3x will give us 0, and then we remain with 3c over c. The c's will cancel out, and then we are left with the limit as c goes to 0 of 3, and our answer is just 3. We will move on to the second example. The second example now is saying, using the first principles, find the derivative of y is equal to 2x squared plus 3x. Again, we are going to use our formula dy dx as equals to the limit as c goes to 0 of fx plus c minus fx over c. We make our substitutions, and after making our substitution, we just expand the function that we are having, and after the expansion we get limit each and every term that is on the numerator by c. We are left with 4x plus 2c plus 3. So now as c goes to 0, 2c will go to 0, and we are left with 4x plus 3. In our next example, we want to see how we differentiate the function y is equals to sine x. So again, we will use the formula that we are having. Dy dx is equals to the limit as c goes to 0 of fx plus c minus fx over c. And then we substitute x plus c into the function that we are given. So we are substituting x plus c into sine x, and then we get sine open bracket x plus c, and then we say minus our fx, which is sine x, and we divide everything by c. Now we want to make use of this identity, which says that sine a plus b is equals to sine a cos b plus cos a sine b. This is the identity that we are going to use to expand sine x plus c. So when we apply this identity, we get sine x cos c plus cos x sine c minus sine x. And from there, I can factor out sine x. If I factor out sine x, I will get sine x open bracket cos x minus 1 plus cos x sine x divided by c. Now I can split this into two fractions. So after splitting these two into two fractions, this is what I get. So I can bring out the sine x out of the limit function since it does not contain the c. The same applies to cos x. I can bring it out since it does not contain the letter c. Now I say the limit as c goes to 0 of cos c minus 1 over c. This, we have the standard results for this limit and it's 0. And the standard result for the limit as c goes to 0 of sine c over c, it's 1. So instead of this function here, I will put 1, and instead of the function cos c minus 1 over c, limit as c goes to 0, I will put 0. So in the end, I will have sine x times 0 plus cos x times 1. And then my final answer is just cos x. So the derivative of sine x is cos x. So that is how we differentiate functions from first principles. I hope this video was useful. Thank you for watching. We meet again in the next video.